Good morning. All right, back to the task at hand. All right. Just reading through the documentation at the moment. Normally, I would be using our commute text, our RW lock. However, because the locking is basically done by SQLite, I don't want to do any extra locking. Maybe ref cell? Mhm. We actually don't want. Wait, we basically want all the parties to go to one central location for the day. Pour some tea. All right. So it is stuck on there. All right. Okay. Essentially, I want to be able to replace the salt for a given slot. But I want the slot, which wraps basically a location. Huh. And why isn't that just referencing a location? This code is so unsafe. Um, Basically, we want new wall states or some sort of self dot slot. And then we would do something here, right? Do magic. That should get us the location inside of here. This is wrong. Actually, oh, interesting. Why are we returning this instead of, let's say, a pointer? uh, Halsey, your C coding is showing. Oh, that's hot. Okay. Why not that? Right? Actually, why not? Well, shared state. Something like this, actually. Then we don't have to interact with that. We just have a mutable pointer to some place in memory. Wow. This just feels so unsafe. I just don't want the overhead because this is going to be like right in the like the hot path. Okay. So in this case, we could say let's cast mute. Oh, on raw pointer. Okay. So we have that. There we go. We have the wall shared state. Good. Dot salt. What was it? File salt. Unreachable code. Ah, there we go. Fix that real quick. This does not need to have a cell. This be the location, like the index here, or the memory pointer? It's okay if it's slow here. State index. Now we have state index. Now in this case, we want to get immutable reference to that. Convert it to a pointer. Okay, getting closer. Option to an option. Really? View size. Oh yes, because we don't know if it actually exists, but it says it's occupied. It's not what I want. As mute. That should give us mutable reference to that, which we can unwrap. There we go. Otherwise, we insert should state. That's interesting. Inline map. Why was it content with this down here? That needs to be a map. Okay. There we go. Found object. Oh, let's so we save it and then where? Here or here? Ah, yes. Cannot borrow it. Bah. Well, we don't have to borrow it. Not this way. We could just refer to the global while inside of self. That's dirty. Okay. Yes. We want to lock on everything here. Well, we could change this now that we are simply pointing to some location in memory inside of our wall slots. We could do something else. Zedervim, thank you for the follow. So let's move this mutex up, as this here is ensuring the consistency of the state. Where's our global? No, wrong way. Here, say mutex, something like that. And here, okay, good. No, we don't have to do that. You have to get a lock in order to do this. Do we use this anywhere? Oh, there. Okay, now the whole thing is locked. We can borrow mutably, which is fine. The other issues go away. Let's find the warnings. That's gone. What else? Sure, that goes away. All right. Couple errors. Let's work our way into the wall log. So we'll do VFS first, then file, then wall. VFS first. Oh, wait, what? This is returning unknown. Wall states, find or create. Ah, we have to lock. We don't care about the poison blocks. Matchups have incompatible types. No. Okay, so we get a slot. We're going to be returning the result. So we need to map that. Where's that? Here and here. State init result map slot, something like that. I32 is not an iterator. That returns an iterator? No. Returns a result. And we can map the result. Oh, I see. Okay, that. I thought I had changed this down here. This bit here. So in this case, this could be a result. Why don't we just store this as a result? State init result. And then if it's an error, we return. And what we can do there, state here. Okay, let's get rid of that. We're going to return state like so. State init result. It's not actually what it is. Underlying init turns in result. Now state is our result to the file state. Oh, but we don't know what the underlying init is anymore, do we? Well, no, that's not true. Because it's either okay, and this means something. What does it mean? It means SQLite okay. So we could change this to be something else, but what are we using that for? Slot. Does slot actually do anything here? It doesn't. We just know that if the init underlying file succeeds, so if this succeeds, our X open, okay, really, see, otherwise we get this error. So let's change this to unit. So it either works or it doesn't. Okay. Slot, we don't care anymore what that is. Same here. Okay, but now state is more interesting. Right? It's either a file state or an error. So this is a little tricky because you have to actually do the write. So if state is never initialized, oh, maybe this was a bug before. What would state have been? We still would have created one, even though the underlying file would not have been correct. Huh. So that changed. But we must do the right so that p methods is set to null. Error. You have error state. Underlying file is unreachable. Same here and here. Okay. No, let's do a match instead. Oh, I want to do this a different way. Let state equals state on match. Nice. Okay. Okay, state. We just passed that through testing. Okay, good. If there's an error, return. Well, we have to set this up as an error. Error in this case. We have to return the error. That is after doing this. That goes away and stays. I think we can do this in two different ways. One there and one here. Oops. Weird. Mismatch arms. Okay. Now in this case, we've already returned the error. This has been initialized. Initialize the Good. Okay. Where are we here? Okay. Now, in this case, shared state, this here, state, shared state, whatever we call it. This is a wall slate state slot. Hmm. Why don't we have some sort of reference count? What was this? No. Good. Starts with 0. I think it should probably start with 1. And we need to make sure to increment that. Hmm. Binder create. That's inlib. Okay. Global states inlib. There's a little bit of a race condition. No, there isn't, because we're inside the mutex. Okay. Increment ref count. I guess fetch added is just parent swap. Fetch add. Seven 715-209. Happy Saturday. Actually, we're in mutex. We don't even need this. It doesn't need to be an atomic int. Decrement ref count. Minus. Okay. And in this case, if it goes to 0, you should do something interesting. Let's see. Maybe the caller that does this should. Okay. Increment, decrement, returning. Okay. There we go. There's our little ref count bit. So in this, we increment the ref count. Yay. Now if we have a vacant entry, we don't have to increment the ref count because, just because, it already starts as 1. So when we create a new shared state, it starts as the number 1. Okay, good. We're going to search for wall close. Now, wall close, we have to know about this thing. Wall state. What is this returning? Wall state dot shared state. Hmm. That's not locking anymore. I want to get this done so I can get back to building the website. Need to get that data replication done. Past 2 weeks have been bug fixes and bug hunting, all of which has been needed and very nice. We now have a much nicer integration test suite, which I think a project like this needs. It just can't live without it. Okay, so what do we intend here? What is okay? I'm going to ignore the previous code and say file.wallState dot shared state decrement ref count. Let ref count equals this. Okay, if ref count is equal to 0, then we do all of this. If it's not equal to 0, if it is greater than 0, then we return, because we're sharing data between many things. So we get our shared state. Wait. I'm going to get rid of that. Okay. That's good. Okay. This was a check to see if we had already closed the file. No need to do that anymore. Now, after this completes, or maybe here, right? I feel like we need to do this in that mutex. We need to hold the mutex as we're doing this. What did we call it? New wall states. Get dot unwrap dot lock dot unwrap. Okay, and we saved this. Okay, there's our state guard. So we check to see is this decremental? We decrement at this point. We're kind of reaching around the mutex. But just ignore that. This is all actually protected by SQLite. SQLite has a mutex. And we have a second mutex. The second mutex is to protect against reads, because SQLite will ensure that mutation only happens for a file in one thread at a time. So SQLite has its own guards for mutations to a file, but reads from the file and mutations to the file can happen at the same time, especially for wall logs. So it's okay. And this here is to keep us from being able to, from creating, let me write this down. Void create, let's see. Log file from creating new all states as we are closing one. There we go. That's what we're protecting against. Creating and closing the same wall state at the same time. Okay. We decrement the ref count, and then we say state guard dot, well, not there yet, there. We need something other than find or create. We need to say retire this thing. How do we do that? Please shared state. We could hide access to the increment and decrement through the state guard. That would be a nicer API. And then we could say, was it really released or not? And then we return SQLite OK based on that. All right. Please shared state. This will have what in it? How do we look this up? Ideally, we would pass in a name. So some sort of C string there. There's the shared state. Oh, the wall state itself has it, the file name. File dot proxy file state wall state file name pointer. Huh. Fascinating. because the file name pointer points to this. Okay. I want a cleaner way to clean this up. So essentially, we have a pointer to this wall shared state. We could iterate through this, find it, and then figure out which one of these points to the index. It's kind of not great. Refer to start at the top again. Here to here, which points to there. All right, I think we have the name. We just get to it in a really roundabout way. But we only do this on shutdown, so it's probably okay. And are we logging that at all here? No. Reverb file dot gives us a reverb file. The reverb file has file state. Didn't we implement things for that? I thought we implemented something for that. Simple for underlying file methods. Reverb file. I guess we didn't. All right. Given we're just doing this here. Unsave. We reference that. Dot state dot. It's file state. Now, file state, I believe we had some common functions on this. Post init does hardly anything. Reverb gives us kind of the global state. Underlying file. Now, does each one of these contain the file name? All state does. Main DB state? Yes. Pass state does not. Interesting. Okay, but we could ask it for wall state. Wall state. Underlying file methods, wall state. What? How does that work? Oh, right. Okay. I don't like this. I like museum suggestion much better. Like a view struct, a wrapper struct for this. See, a lot of this just pokes into the underlying bits, right? Which is fine because we're just trying to call some sort of pass through. But here, right, we have some weird things like main DB state, p methods, wall state, reverb file. In this case, we just want wall state because we know we're in a wall log. So we want file.wall state dot file name. Interesting. We don't want. Why is that a ceased like a stir file name? Really? Why aren't we using cstir and cstring? I know that we were relying on this being UTF-8. Hey, Blurry Cat. It's going well, thank you. How are you doing? Because now I have to convert it back. I don't like that. Why not cstir? cstir? Yeah. All right. For funsies, we're going to change this into a cstir. Because why not? Hmm. Well, what's interesting is that this is pointing to something else. Where do we create this? From file name from UTF-8 pointer. Wall state. Fascinating. Oh, glad you're doing well. From pointer. It's unsafe, of course. But I think we should have our own. Essentially, we should have one of these and then copy it into a C string. And looking through that again. So we have a file name pointer. And that's just a pointer to some C data. This here. Basically pointing to that after we've validated it's correct. I want to change this just to C string and break everything. C string, creating a C string. it would be easiest to have C stir, basically go from pointer, and then we can say to owned on it. Let's see if C string has that. I don't think it would. From vector as bytes from raw. Retake ownership. No, we don't want that. From bytes with null. We have to convert the pointer into a ref. Okay, let's go C star from pointer. Okay, unsafe function, add unsafe block to string data owned. That's a C string now. Ta-da. Okay. Now, this thing here. Can I just get rid of this? Oh, and static assertions. Oh, I'm going to miss you. Okay. Then we'll check to see whether or not removing static assertions broke anything. That goes away. Sure, we broke a couple other things. Syntax error. Oh, right. We were getting the file name. All state file name. Perfect. As cster. There we go. File path. Interesting. File path. Path buff. Into path buff. This is on box of a path. Okay. And that's a path. From. There we go. String path buff. OSter. Can cster go into OSter? I know we could go to string. Cster, yeah. Box path for path path. A OS an OS string might actually be a more accurate representation of this data. Strings are always UTF-8 in Rust. Let's change that. Self to file name, OS string. Is there a from pointer on that? From encoded bytes. Ah, no pointer. From C to Rust, from here. No. All right, forget that. I gotta make some progress. C star from pointer. Good. Syntax error here. File name. It's a C star. Release shared state. File name. That's owned. This is a C star. Skipping these for a moment. C star. Yes. Here. File name. Where does this get called from? Rotate wall. Two string lossy. Expect. Let's extract this into a variable real quick. There it goes. Okay, extract. Ha! Into variable. Okay. File name, same sort of thing. Where, okay, wrapped around. What do we have here? Let's zoom in on this side. File name pointer. That one's fine. Fine. Take salt, commit start. Okay. Release. Fine. Main DB. Ah, yes, here. Come on. Good. Now the rest of these we'll fix later. This, though, we'll fix now. Release shared state. We have a file name. We need that. I don't know exactly what the error would be, so we might change that. But we have to get this state cleaned up. And so we say we're releasing shared state for a file name. We'll get this data right away and decrement the ref count. If the ref count's 0, we will say all good. Otherwise, we'll say not good. However, this should probably be a bool. Turns true if the state was freed. All right. So um, name in this case is a C string. All right. Well, let's just work on it. Self dot name to slot. Do we want the entry? No, let's just get it. Now, in this case, when we get an entry, that's the file name. I don't know if that will work because the type is different. The type on the name to slot is C string, unless the compiler knows the association between them. fix that in just a minute. Of course, that's a result. Good. Name to slot. Let blah equals that. Ah, slot state index. Shared states, state index. State exists when freeing it. Let's see. Name state exist. To know whether it's. No, no, I want a mutable reference to it. That's right. As mute state dot. I thought we had a decrement. Oh, it's an option. As mute. Wall shared state. Does that not have decrement on it? No, it doesn't. It was the other thing that has decrement on it. To move this into this call. don't want that either. I want that. Please shared state. State index. So if the ref count reaches 0, then we just delete all the state. Which means we set none to its entry here, and we remove it from the hash map. Let's remove it from the hash map first. No, let's do it the other way first. Self dot shared states state index. See what the none. Oh, do it. Okay. Fascinating. This one, borrow Q. Okay. And this one, borrow Q. That looks the same. Oh, I had an ampersand. Habits. Okay. State. So we needed to get that. We don't actually need this. We need to get the index. Then we get rid of stuff. Is there anything that we manually have to free? No. Close will free this. The rest just goes away. Yep. Release shared state. I think this is correct. We don't actually have an error. I know we could say this except here is the error, but that's more of a validation that I've made. It's kind of a presumption of the code in that if somebody has one of these states and it gets called into close, then this should always be valid. Okay, now decrement goes away here. So what we end up doing instead, we have the state guard. State guard dot release shared states file name. Oh, file name, where are you? File name's down here. If true, right, what's true? Returns true if the state was freed. Okay, so if false is equal to this, we return early. Ref count goes away. Oh, file, yep, file's good. It's good, ref count's gone. State guard, all right, release shared state. Not borrow, state guard is mutable. It's not declared as mutable. Change it to be mutable, thank you. All right, I think this is correct. Let's review. So as we're closing, we lock on the mutex. We release the state. Possibly release the state. If we don't, we say we're fine. We still have more references. There's one more place I think we need to check this. So in this case, new all states dot get dot map, sure. See, that one goes there. This one goes there. Goes away. There we go. just to make sure. Now we pass all of this information through. Set salt. Shared state replace salt. Oh, we don't have a salt. No method salt. Huh. Option 2. Hmm. As rev. There we go. Salt works. Take salt. That doesn't exist. Let's start. Basically, same sort of thing as salt, but with commit and Make commit end. Okay. Isn't this just like replace? That's not what I meant. Huh, there we go. Why don't we just call replace? Take should just be replace. Hmm, let's see. Where is the rewrite lock? There is no rewrite lock. Let's just convert it. All right, underlying file. Should be either right there. Ah, function call. I don't remember. I'm gonna pour some tea. Hmm. Got that. Now this one. Now before we were calling set commit end. What does that do? It's not, was it in, I don't think it's in here. These are the new ones. Set commit end would set it to true. So we could just say set commit start to none, but we're not taking an option. Oh, this is for commit end. My mistake. Yeah, we could set commit end. To true. Replace commit end with true. And it might even compile. Cargo. Let's see. Close, exit, close. Hmm, okay. Fascinating. Shutting down. Oh, we have multiples being printed out at the moment. Yeah, not going to debug that. Failed. 7. Okay. Most in the gauntlet region. Good. Well, that that's an improvement because because the test we were chasing basically required it, and we changed some of the behavior to solve it. Let's do just this one. I want to say, does that test pass? It does. I'm going to read through the log real quick just to validate. So what's happening? We start up, load the VFS, set up the FIFO, open a database in thread 1. You can see that the database is becoming opened, setting the journal mode to write-ahead logging, checking for other journal modes and the existence of a previous wall log. Then we open the journal file, get rid of it by deleting it. Thread 2 does the same thing. Well, it opens the main database. So there's our main database opening. Thread 1 is told to initialize the database, which really just ensures that there's structure to it and inserts some data. So we open the wall log in thread 1 maybe. Check for file size, write some data. Notice that the seasoning, the salt on the file is changed from nothing to something. We'll write some data, notify the FIFO. Write a couple times. Good. 1, 2, 3. And then what happens? Thread 1 is told to close the connection. And it does so. Good. Well, does it close the connection? I'll sync. We'll read. So it looks like we synced stuff to disk. We read some data out of the wall log at a specific offset. We're told to close. And it said that, hey, we're going to rename it. Why would we rename it? Okay, the second connection was told to close. But we deleted the wall log. Why? Were there no references? Only one reference? Because rolling the wall log happens only in 2 places. In wall close and X close. It's not X close, it's just it happens when we go back to the beginning of the file or when we try to delete it. That's right. Second connection is told to close, which it does, and everything shuts down. Fine, but why does this happen before the second connection is told to close? Okay, how many times was the wall log actually opened? Once. And the file pointer is 56C0. Oh, it was only opened once. That's a journal file. It's open. That's not a wall log. Here's one. was only ever opened once. Really? Init. Oh, we didn't actually write data from the second thread. That line was commented out. Okay. Again. Okay. The problem still exists. Even though we made all those changes. What do we have? Second insert, here's one opening of a wall log. First opening, 5640. And what's the other one? 4BC0. Close. Connection here. So that's the first one. This seems wrong. Why would we have done that? Wall close. On the first one, right? The amount of data in there, or the references, should be 2. Unless those file names are subtly different. I don't think they are. Those from Gauntlet Arena multiple thread closing DBs. That seems the same. Okay. And then we get to the point where we are trying to close a connection. We start closing it, and it never finishes. So wall close. We see that this happens for the first one. Feels like something's not quite right here. Because we get down to this point on the first close. Release sharded state. If ref count is 0, it's true, otherwise it's false. Let's print out what that is. Log warn. Well, debug's fine. Hmm. U16 format. You might. Oh, that again. Ref count. It's 0. Why are they not sharing? The threads are not sharing. They must be more friendly with the other threads. Increment. Oh, that's never called. Well, maybe that could be the issue. All state slot. Here, we want to call increment. And it's just self.increment ref slot with the index. And again, Oh, it's 2. Interesting. And what was it before? Okay, we're going through adding some data. Second thread is asked to insert. It opens the wall log. Seasoning is changing? What? Why would that change? That doesn't seem right. We'll read. Hey, museum. I can't link memory if you don't bump any references. I had a coworker that used to laugh at all my jokes during in-person meetings, but never during a Zoom meeting. When I asked why, they said they're not remotely funny. Oh, all right. Copy. That's going straight into Discord. There we go. Okay. Um, so where are we? DB close start. We're looking for ref counts. So here, lib 845. Where's lib? Lib. Did that only happen once? I should have had that closed twice, right? So scrolling back down to the bottom. So one close. Here's a second. Let's see. For thread ID 1, close. For thread ID 2, close. So in this case, we should then see a ref count. Ref count is now, boom, 2. Oh, well, we started as 1. So now we're off by 1. All should state. Again, now it's 1. So we go from 0 to 1, 1 to 2. Oh, that's a little bit of a tongue twister to read. I was looking at some perennials recently to start up a flower garden. I saw that the local monk monastery was selling flowers, but I cannot condone that. Only you can prevent florist friars. Ouch. Wow. Oh. I like that one. That's good. Okay. The ref count is now what? Why is the ref count 1 now? I don't know what's going on. I've lost track. I'm tired. Release shared state. Okay. So we decrement the count is now 1. But here we are close is being called, but it doesn't do anything. This is because the call to close is hanging, and I don't know why it's hanging. I took a shot in the dark and made all of these changes, but it doesn't seem to have made a difference. Except we did fix some other bugs. So we fixed this. global hash, yeah. So these two pieces we actually fixed. So this is done. This is done. But this, okay, so technically I believe this is done now, but we still have the same bug. Tired? Well, last night I had a dream. I was a muffler. I woke up exhausted. Yes, that's great. All right. So there is a call to, where is it? It's in Gauntlet bin here. This never returns. So we have two threads. Each one of them has a connection. The first one will take their own connection. This is not shared between threads. Each thread has their own. First one takes, closes down. Fine. We see the ref count become 1 in our VFS. Epic blur. That one's funny. Copy that one too. Let's see. Anyway, okay, but so first thread does this just fine. Second thread, it pauses here. We do not see inspect error get called. It does not return. It never reaches DB close. I have no idea why. I thought this was an interesting test to do. Two threads opening. Let me come back to outlet here. So now we have thread IDs. What does close do? It's this close here is sqlite. So we come into close, flush prepared statement cache, borrow, mutably, map error, and just nothing ever happens. Flush prepared statement cache, flush, or immutably clear. Some sort of map. I'm just looking for a lock somewhere. Close shouldn't block only, so the VFS isn't returning from its fsync wrapper. Let's check that. Interesting. So here we have the first wall close. This bails out early, right? We see there's still a ref count. So this should return correctly, but early. Let's make sure of that. Wall close. Here we return early. Let's just say returning early. Okay. So in this case, we lock, and this is a new way of locking. So we have a mutex on this here. There should be no contention. We return here, and the guard is dropped, right? So we should see that. The second time through, we do not even see the first call to wall close being done, which is suspicious. I've been thinking this is between us and SQLite somewhere, or rescue light somewhere. So again, returning early, 2 threads, right? One returns early. Rust 24 changed those rules a little, but it shouldn't be a problem. Interesting. I don't think I've set my project to use 24 yet. Hmm, okay. But you can see that the first call to close happens in our VFS. Our VFS knows about it. The second one, our logline never gets called. So the last thing we see is this call here in the gauntlet binary, which is just before the rescue light close call. And then I suspect the rest of these are actually on the other thread, because one thread is just hanging out. Wouldn't we see the log line? We're not seeing the log line the second time. I guess it might be reordering, but this is debug mode, right? Yeah, same thing. Same thing happened. Ah, okay, so log segments use a fence under the hood. Well, that's good to know. Okay. So we only see the first one. We do not see the second one. Again. Yeah. 8388. Let's see, file close. This is on 4930. I have wall sync being called. I see. Could be reordered, but that'd be an OS buffer based thing. Got it. And Roosh, thank you for the follow. Hmm. I don't know why this would have paused. I don't really want to add logging to rescue light. Borrow mutably. What's DB? Ref cell interconnection. On close. Pre-update. Interrupt lock. Lock. Interesting. Maybe something did not get released. What is interrupt lock? Or only panics if it doesn't work. Hmm. Interconnection. It's unsafe to call sqlite close while another thread is performing a sqlite interrupt and vice versa. Hmm. However, the main copy DB is unprotected. Otherwise, the long-running query would prevent calling interrupt, as interrupt would only require a lock after the query's completion. By using serialized threading in SQLite config, I have not configured anything for that. So in this case, all I did was try to act as a consumer of SQLite. So if we look at Gauntlet, where we open a connection, or is it, I think I passed it. We open here, default flags, etc. I think you're talking more about config at the compile time setting. SQLite, open full mutex. Oh, you can do it at runtime. Serialized threading mode in SQLite parlance. Should probably never be used with SQLite as we ensure thread safety statically. Critically, even if this flag is used, the connection is not safe to use across multiple threads simultaneously. We have different ones. To access the database from a database from multiple threads, you should either create multiple connections, which is what I'm doing, one for each thread. Doing that, if you have very many threads, wrapping the connection in mutex is also reasonable. This is because this is both because of the additional per connection state stored by SQLite for varied statement cache, and because not all of SQLite functions are fully thread safe, even in serialized. Okay, load. Oh, okay. So default is open no mutex, but we could set that. Yeah, I don't think I am, but it would be interesting to see if that changes things. Here, let's go back and say we're opening with VFS. Let's do where was it? I want the default, but I want to change just one. There. Full mutex. Like so. Let's try that and see if it has any behavioral difference. No. So our ref count is still 1. And boom. Hmm. So yeah, I have a thread, excuse me, a connection per thread. Now, I have been able to, here, let's go back to tests. So in this case, if we do not load the VFS, let's ensure that everything works normally and I can shut down everything. Without the VFS, we will not see the log lines though. Okay, it's shut down. All right, we just see the logs, the debug entries from our integration test. So it closes down just fine. So something I'm doing along the way of shutting it down causes this error. If I do not set a journal mode, let's see, then it shouldn't use the write-ahead logging, which would be another interesting kind of bisection of the code. It says it failed. Interesting. Attempting to create a non-Waldy. Okay. Yes, I have a check that prohibits that from happening. Um, we could disable that for a moment. That's not it. Forgot to copy. There we go. There's probably one more check. Yes, okay. This was in main.db. This is in main.db. In write. Huh. Da, da, da. Test gauntlet. Attempting to open a non-walled. Really? Oh, to open versus create. There's a second close, first and second close. So if it's not using the shared wall state, it works. Okay. Let's add more to the bug notes. Bug notes. DFS is loaded. Yep. Just verified that twice. How much do rainbows weigh? I don't know. How much? Huh. That's funny. All right. We were not able to validate this. That would be interesting. So it could be that. Well, hold on. Let's see. Not really related. If I wanted to be creative, you could store the pointer to the arc in a hash map. Oh, interesting. Well, that's nice. Okay. So it doesn't, so it only happens if we're using the wall log. Yeah, I saw that as pointer. You can also store that pointer in the FFI. Yes. Undo this and undo. Where'd it go? Main DB? Those are back. Okay. So if we go into wall log mode, what happens with wall log mode? See, I suspect it's because we're trying to abstract away the underlying file. And because we're not actually closing the underlying file, some sort of locking is not being cleared up in SQLite itself. Just neat pattern. Servo has their own arc library. Triumph. It does this a lot. Triumph is like an arc, but without weak counts and better DST support. Check a text message real quick. Hey, nice. I was doing some tech support for my brother-in-law yesterday, and everything went well. Yeah, got everything done. Okay, so going back to Xopen. I don't know how to use computers. Classic response from you. That's funny. Is my manual ref count thread safe? It is because SQLite is blocking, right? It has a mutex for us. Oh, and so that's where one of the logs is. And the other one is because anytime you try to access that, the global wall state, where'd it go? Oh, here it is. We have a mutex, and changing the atomic pieces only happen if you have the mutex currently. I want to rename that. Just call it wall states. And SQLite, well, I can't call those ref count functions. That's correct. That's correct. It does not. There are only two places where it does trigger those, and that's from the wall close function here, right, where we release shared state, and in the xopen call, whatever that is. So xopen, we go through, do some stuff, and we find our create here. So we have to get the lock here, the wall state, or we get it Didn't it do it? Here. Oh, parking lot has a deadlock detector feature, which may be helpful. See, I don't actually think it's because of our logs. I think they're okay. Partly because we don't see this log line the second time it comes through. I suspect that and in the when we release the first one, we do see the wall close returning result. And let's compile and run it again. Okay, here we're returning early, so we know that the mutex was released. The second time, we don't even see a call to wall close, which is just bizarre. It should be happening like in this area. Main DB close, that's for yeah, the other connection. It's tempting to try the deadlock detector. I suspect what's happening though, and I suspect that because we not doing this on the first time through, that it causes some badness. I don't know, maybe some weird pointer. Let's close remove the VFS from the sqlite state. Um, it does not, no. I have it registered globally. Yeah, it's a singleton. It's permanently registered. Both threads call the init function, but they use the same shared state. Okay, let's pretend that we don't do this, and we see what happens. Well, maybe we don't do this. Deadlock, curiously. Nothing on the Rust side calls this. This is only called directly by SQLite. We set up some pointer for SQLite to call it. This is inside the function. We're just logging about it, more logging about it, more logging about it. Yeah. What triggers it? Is it on SQLite connection drop? Oh, I see. Um, it happens in two places on connection.drop or if you call close directly. And I'm calling close directly as part of the test. So here in test gauntlet, we purposely call close for each of the threads, thread 1 and thread 2. Do I log before the close? I do. To see if it's even getting there. Yes. So the closest that we've gotten is been here. So, nope. This is DB close. So in this case, we see DB close start for both, and we see this line for both. For the first one, we will see this line. Okay. So for the second one, this never completes. And this, in this case, the connection is all SQLite. I suspect that it's because close here has this lock at this point that is not available. But I'm not sure what locked at the previous time. It's either this is all working and SQLite itself, which its call happens right here, has something going on inside of it. Absolutely possible because our abstraction causes SQLite to share the same underlying file between two threads, which, dare I say, is maybe not correct. And I should have some other sort of communication mechanism between them so that they know as they go to write that they have to refresh or something. I don't know. Let's see. Can I just ePrintline here and it'll rebuild it, even though it's in my registry? You have to patch it. Okay. I want to think through this for another moment. So, I want to explain the mental model. Where's my drawing program? Oh, there it is. Here. Yeah, let's move to some other place. It's going to look very similar to that, though. So what we have thread 1, T1, and thread 2, T2. Right? They both have a connection. We'll call it C1 and C2. C1 and C2 end up calling into the VFS, right? The VFS under the hood has this shared state. Okay. But let me take one more step back, though. What would normally happen with SQLite is that when you open a connection, you get some state about the underlying file and so forth. So you have, let's say, U1 and U2, right? Underlying file. That's the underlying file information. And then when you call close, it closes that state. And then you could close the other one and it will close that state. Now, the VFS basically has them work on the same piece of underlying data. We'll just call it U0, right? And U0 would be opened by the first one here, and then closed by the second one. And I suspect that because the first one never had its data closed, that some internal state in SQLite is foobarred. All right. Yeah, let's add that. Um, let's see, where's RS, sqlite, repository, code. Just gonna do I already have it? No, I don't. Okay. It's clone, blah. The interrupt block is only used by native functions. Oh, I see. For a create function and so forth. Okay. I was looking through it the other day as well, and okay. Well, it's IO, sqlite is equal to path, which is // Rus sqlite. And this, let's see, they have this folder, but think it's they just use a top level for their main crate. Yeah. Sqlite, Helix. Oh, actually, we could do this with the other editor instead of here. Let's go back here, jump into this. Okay. Oh, it didn't pick up the okay. Yep. Let's do that. Buffer close, yes. Oh, it could be the flush that's blocking. Interesting. This does not appear as though it worked. Oh, because the version is different? I think we want this one. Yeah, this. Okay. I have fought with SQLX, libsqlite, um, and rusqlite over dependencies for way too much time. It's been days, and I don't like losing days to dependency management. Oh, SQLX, it uses full mutex incorrectly. Huh, interesting. Maybe I could patch this just for the VFS. Well, because we don't use SQLX here. No. Oh, that would be useful. How do you rename a package? Um, just specify the package name. Huh. Okay. Mm. All right, now it's called Rusty sqlite, and we'll go here. Oh, I got it backwards. Package says the original name. Okay, the key and the O is the new name. Thank you. And Rusty sqlite. Here. Okay. Not sure if this will fix the patch. Interesting. Okay. Oh, do I need well, so here we need a Rusty as well. Rusty sqlite. Vendor it. All right. How do we vendor? Just one. Actually, we probably need to vendor a number of elements. Well, hold on. Actually, did this work if we did this? So if we just build this, and it doesn't know about the others, right? Because we're just going to do like a cargo build HP, reverb VFS, and we do dash dash tests, zero test. Actually, it doesn't have any tests. We're good. Okay, so that built. Okay, so now Helix. Where did we need to go for this? This was in. I'm gonna remove that. Remove. Oh, no, no, no. I need that. Rusty QLite. Electric cargo. Rusty QLite goes away. Yeah. Then we'll just build the pieces individually that we need. Go test P gauntlet. Oh, but gauntlet needs Rust QLite as well. No, wait, wait. Why did I put that with the VFS? That doesn't make sense. I don't even think this matters anymore. For VFS, we ended up removing most of this. Yeah, that's a red herring. Okay, I did the wrong thing here. This temp file. Okay, temp file is not used. Enter process. Not used. This is used, but not in debug mode. That doesn't look like it says inner process. Oh, it says rescue light extension in it. Sure. That's not really a thing. It goes away. Test utils. Okay, that goes away. Good. Fitting sys modules that you don't control is almost always wrong. Yeah. I've probably spent literally over 24 hours dealing with that, trying to update. Then it's like, no, you can't do it. And you try. Let's look at Gauntlet. Gauntlet does have SQLite. So let's put the patch there. Go build. That should be Gauntlet. Let's do a test. Oops. That's what was it? It's cargo. Dash p. Yeah. Hmm. See, I don't think it's using the right file yet. Gauntlet, cargo, and then gauntlet. Have the override. Does it? Oh, does it have to be in the workspace? In which case, that's going to suck. Yeah. Well, I guess I could do the opposite, right? Basically fork sqlite and then unpin the version, which, I mean, would that work? Would that make my life easier? I would doubt that sqlite. True. Okay. That's going to be. Ooh, who uses it? Okay, well, let's do the opposite. What do we need? We need gauntlet. Here. It's doing nothing, so it's doing something. Yeah, I'm not sure. LSP restart, maybe. Wait, Taplow? Not found. Taplow. What VFS? Lots of stuff. And then this. Cargo jack. Hmm. Okay, maybe it's okay. Taplow. Is that Tommel? Oh, okay. Thank you. All right, so going back to Gauntlet, here we're going into, look, it's in the right spot. Close, print line, um, close. Let's call it Rusculite, close, start, middle. Here, let's, B4, cache clean, B4 close, or map. Okay, recheck. Okay, cargo test. And cargo build. And that one. That's not the right test, though. Which test did we want? We wanted this one, multiple threads closing. Oh, Fish finally released their Rust rewrite version. Huh, it just works, but it's in Rust now. Nice. Oh, look at that. Before close. Okay. It's interesting. So here, let's see. do I do? I missed the shift on the double quote. Interrupt lock. Turn early. SQLite 3 close. All right. But as far as doing that cargo vendor hack, it's wholly not intended, and you should always try to get patch or the old replace method working first before doing that. That's why vendors, all depths. Yeah. Let's make this compile. More time. Ha! It is in SQLite. Oh my goodness. Okay. So the first time, SQLite 3, wait a second. It doesn't return the first time, does it? Oh, wait. Returning right there. Why are these in? Oh, these are in different orders because of the thread. Before cache clean, before close, close. Okay, so what do we have? Here we have an insert. Then we say thread 1, close please. Good. We haven't done a thread 2, close please. SQLite 3 close. What comes after SQLite 3 close? Here we get decode results raw, which we do get decode results raw. So our code, the VFS code, did get called by SQLite. We have a ref count, decrementing, whatever. So I can see 2 message, 1 message, and reorder. Yeah. I think because we're doing things serially, it actually reads okay. We see our VFS logging here. Right. So we see decode results raw returning. Okay. Returning. And where's that map? Oh, then before map, we see that happen. Okay. And then close. That one though. Yeah, let's add the thread ID. PRINTLN bang. No, I want the global search. Want just the ones in Gauntlet and oh, this isn't going to search where I want. Here. ID. Build and run. There we go. So we have our close. We tell the application to close. Then we have basically some log lines just before sqlite. And here's our connection, close. We're debugging the connection. We start to go in. SQLite close is called. We get decode raw results, returning before map. When does this one happen? Long editor. Here. Well, it's here. I don't have just another close without an ending there. Yeah, that's only in one place. Why is this happening twice? Because drop's being called. Interesting. Okay, so thread 1, which is called thread 2, hits this point, and close is called. That's by gauntlet here. We should see a DB close exit just after that. Let's verify that we see that. So we do see this, but that, like, why? Where's that coming from? It's the one that we see before. Start at the top. Thread 1 closing. These are happening out of order. Why is this happening out of order? So first, okay. So we see our connection starting to close. Then we say before cache clean, which wasn't here. It's actually here. Like it's called. Oh, actually, this is step 1. I should remove this. And now I can kind of see the sqlite before and after. And then there we go. Oh, thank you. Rancher Mutex and parking lot. I use those in Java all the time in a game server. It's just what we had. Here. Okay. There we go. From the top, thread 1 told to close. Good. There's our debug line. Now we have sqlite. Good. Before cache clean, before close. Then we're doing close. Notice that's alone. There's nothing else. That's the first thing there. Close returning. Before map, which is mapping the return type. Actually, here, I need to make sure that I don't have that open in the editor anymore. for map. So we map our return type, and then we say we're completed. But this here is perplexing. Where did this come from? Same thread, sqlite close, and then we completed. What? So close, completed. So before map and completed. Before map completed, and there's a close. I am in disbelief. Does this do it? Somehow? 'Cause essentially, that would be from here. Right, this line is getting hit twice. And for so, oh, maybe this check is actually protecting from shutting down twice. Why? Why would that happen twice? That seems really weird. Self-dot, okay. So they are setting self.db to null at the end of this. Does anybody else see a call to that at the same time? That's fascinating. Right? It'll only keep it if there's an error. Makes complete sense. Oh, and then here, maybe because I'm dropping it. But I would expect if it was the case that, hey, it's being dropped, that we would see it after Rusculite completed. No, because Rust knows that I'm dropping it and can push the drop further up, which happens to be in here. So here, Rust knows that we're going to drop this. We don't use this anymore. Connection, we took it. Right, so where does the lifetime end? Lifetime ends. Close. We're done with it here. It's been set to null, right? And I can drop it at this point because we're mapping error and we know there's no connection. Okay, so drop must be getting called. Let's look for drop on connection. Drop. Okay, thread one, closing. Close. There's our close. Map, yes. Connection drop, Rusculite close. Completed. Huh. Fascinating. in my code, I only have inspect error and map error. This is the last place I actually use it. This close here. So it looks like the lifetime was pushed up. Right. It's either at the question mark or at the line 121. So manually do drop to be explicit about it. Okay. I think in this case, we're going to see it move in the log lines because here it's happening much, much earlier. It feels like Rust has moved the lifetime up, well up in the case of success. Close won't let me have it. Oh, you're right. Hmm. Why isn't this? Oh, I have to save it. Okay, so close consumes it, right? So self lives till here and then drops because it's not needed anymore. And then drop calls close again. Okay, which is this close. So we see this twice. Okay, but that's okay. All right. So that all seems understood now. Now the second time through, so here thread 2, db close. We get to SQLite close and nothing. Before, when we get to SQLite close, we would see our wall log here. I call the wall log. Music? Ah, now this is Pretzel Rocks. I don't know, it's the Chill Guitars channel, Pretzel Rocks. It's called Reflection by Sherry Finzer and Darren Ma. Can you hear the music? I see OBS. Here's the music. Yeah, you're welcome. Let's see, I might have a link for you. Oh, I do. Okay. I don't know if that's useful, but maybe. So the FFI is in some weird state. I assume the null assignment is getting rid of your user data pointer. Yeah, I think it's because of where'd my picture go? Because of this, right? Where thread 1 and thread 2 are both using the same underlying data. And this here, which is a little bit of a black box to me, the underlying file, I think somehow has information about stuff up here. And that's causing an issue. So let's try it. Wall log SQLite close. Okay, so we're not returning early. Yellow driven development. Absolutely. This is how the big boys do it, kids. All right. Let's just comment this out. So we end up. Let's not do that either. Or this. Oh, at the end of their close call. Got it. Oh, I'm almost done with this one. Let's try this. SQLite. Okay. And then yeah, I would really like to okay. That didn't help. Same issue. I uncomment this stuff. I'm going to put it back in the good state. Or basically what I thought might be a good state. All right, end of theirs. Close call, connection drop. End of their, that would be in lib here. Own is okay. Decode this one here. It does in one place. In one place, it mentions a lifetime of stuff. And that's that has to do with a file name. When they pass the pointer in to xopen, they guarantee that it will live until close is called. And that's it. It's the only place I've ever seen a lifetime mentioned. All right. Nope. Same issue. Okay. Now, I think this is because they are using shared state. And I suspect that it's not because of the shutdown code, but it's because of the initialization code. And so when we come into BFS lib and we go into, where is it? Xopen. It's in VFS. Suspect it has to do with finder create, not actually calling and initializing the underlying file for a call to open. So what does that SQLite close function actually do? That's a great question. That let's check. Hmm. See, check index. No, Unix close. Here it is. 2184. For those following along at home, there's a link. Error equals all. If it's wiping out your user data pointer, it's probably doing a guarded return. Hmm. That's why we don't see a call into the VFS. However, we also don't see a return to sqlite. Close Unix file, leave Unix mutex. Mutex enter. Unix mutex enter. I don't see any early returns. We have an assert though. So if the shared memory is not good, just calls F close essentially. Yeah. Unix big lock. Big locks are the worst locks. Okay. So I suspect it has to do more with initialization. Right, so when we get called, I think it's expecting us to have certain things populated and for other functions to be called. Let's see, simulate form. So an X open is called. Do we have close? Oh, that's for the IO methods. There's X open. What if I delay the second close by a bit? Oh, just to see if it's a race condition? Sure. Now, where shall we delay it? We could do it in the test itself. Millions, let's say 30s. No. File control will sync. Actually, we're getting this sync called. Has that always been there? I'm gonna scroll up a little bit. Let's see the previous run. Wall sync. Wall sync is being called, and it's not returning. I did not, and I was blind to that. So it doesn't look like 30 milliseconds is enough. Sync. See, we just call, well, the underlying sync, we pass in the flags. What does this do, though? This calls the sync method. Why would this not return? Let's look at Unix sync. Um, okay. Oh, thank you. um, yeah, I hear that in my head now. Eventually, we need to have a phone call so I can actually get the full museum like voice in the back of my head going. Because there was a voice in the back of my head that would represent you well. Like, is it like the Ryan Reynolds? Is it like, what do you got? Like, I don't know. It could be, I don't want to be assuming anything either. but I'd let you choose. What's the voice that I should hear? I was thinking Ryan Reynolds just because it's a little, you can have that like sarcastic tone really, really well. Pick a voice. It's my inner monologue. Okay. Your museum has a voice. So I didn't want to say it earlier, but the first voice that came to mind was actually like a Mike Tyson, but like a super technical Tyson voice. Do I have a okay? So forgetting the voice thing. Um, so do I have a valid path to the file? I do. So this Unix, this file ID here, you can call standard FS call on it. Actually, I'm a little concerned that maybe this is the wrong one. This is in what is this on? This that. So SQLite 3. So we're just passing the sync to the underlying file directly. And just for funsies, if I comment that out, okay, I'll try that just after I validate that this here. SQLite 3. Just want to see it. Ah, now it's gone to read. So it does look like something like it's pausing for some reason. SQLite has a weird KV for compiler assists. Huh, interesting. Some more water. All right, well, I'm out of hot water. Excuse me. Okay, so let's start this for a moment. What is being synced? Just want to. I saved. I saved. Okay. Put my SQLite hat on. Oh, ooh, ouch. Um, so in this case, we're syncing file, but which file is this? 4500. Is that the one that we opened? Is that our underlying file? It should be our underlying file. So that's the file handle that they gave us. Wait a second. Is that correct? Because they give us. This shouldn't be using underlying sync because the underlying file isn't at that location. Underlying sink is for all the other types of database goodies. This is. We should be using this one. We're using the wrong pointer. There's your problem. We're using the wrong pointer. Okay. So this makes maybe a structural log. And yes, I was just thinking that too. I just hadn't spent the time doing it yet. Um, yeah, this here needs to go away. Underlying file. So okay. Let's change this. Get UI first. Um, some of this I feel like I need to undo. This change here. Let's undo that. This can go in. All right. Screw it. Let's make a change even bigger. I like it. If you ever get locked out of your house, talk to your lock calmly. Communication is the key. I like that one. I gotta send that to my family. It's, all right. I think I need to take a break. It's been 4 hours, and this has been an amazing session. But I don't think I have it in me to change these things at the moment. So I'm gonna go play Deep Rock Galactic, and I'll probably, I don't know, find something alcoholic and make sweeping changes to the code base later. And I will introduce some new bugs to you guys tomorrow. All right. Well, think of the YouTuber you someday. Yes. New bugs is just content. Yeah. No. Well, thank you, everyone. And I don't know if y'all have any suggestions for who to raid. Say, um, not seeing any rust. Why did the abstract painter go to jail? I don't know. Why? Or framing an innocent canvas. Oh. Oh, yes. Let's read Mr. Halsey. He's streaming. Oh, it's all good. Um, well, I am so glad um that we found the answer. Reminds me of a joke, actually. It's kind of a dig at intellectuals, if you will. But the joke comes somewhere like this. It was a, I don't know, I'm just going to pick a doctorate. Let's say there was a mathematician sitting in his desk in some big Ivy League school. Right? He's been there for 20 years. He's, you know, thinking big thoughts and all that. And he's from the generation where he likes to smoke a pipe. So he's got his pipe and he lit it up and he's smoking and he's thinking about big math things, right? Big brain math stuff. He's sitting there in his office, puffing along, looking out at the campus, out the window and the trees in the autumn. And his pipe's getting a little low and he decides to reload it. He taps it out into his waste bin and he gets it going again. And he's just sitting there thinking, and he notices that there's an odd smell, and he checks his pipe. Everything's fine. He looks, and his waste bin's on fire. It's like, oh goodness. He stands up, and just as he stands up, the basket, which is happens to be next to the curtains, it catches them ablaze, and they just go up. They're ancient, and he's a little concerned, and he steps out of his office, and standing from the outside of his office, looking in, the room is just full of papers that are just catching, and one thing after the next, and can't figure out like nothing's happening. The sprinklers aren't going, nothing. And he looks to the side of his office door, and right there is a fire extinguisher. He's so relieved. He sees the solution and walks away. Yeah, that's all I got. Um, Thank you all for hanging out. Till next time, I'll be here tomorrow. After getting a telescope as a child, I wanted to be a meteorologist. I was so disappointed when I found out it was about clouds. All right. We're going to run raid CM grouping. Why not? Haven't done that in a while. Till next time, y'all. Bye bye.